All right, let's jump right in. Today, we're looking at a pretty radical alternative theory for a physics phenomenon you might have heard of, the Stark effect. This entire explainer is based on a paper by Miles Mathis, and he's not just tweaking the old model, he's proposing a whole new way to picture what's going on. So first, just a quick refresher. The Stark effect, discovered way back in 1913, is what happens when you take an element, look at its unique light signature, its spectral lines, and then you hit it with an electric field. Those lines shift and split. Now that part, the observation itself, everyone agrees on. The real debate is about why it happens. To really wrap our heads around this different perspective, here's how we're going to break it down. We'll start with the author's critique of the mainstream explanation. Then, we'll build up his new core theory. And from there, we'll see how it all comes together to solve not just the Stark effect, but maybe even the nature of light itself. Okay, so where do you even start if you want to challenge a century-old theory? Well, this author begins by poking holes directly in the accepted quantum mechanics solution, arguing that, logically, it just doesn't add up. The first big problem he points to starts with the simplest atom there is, hydrogen, right? It's got just one electron. The standard theory says spectral lines come from that electron jumping between orbits. But here's the question. How can a single, uniform electric field cause that one lone electron to move in 5, 6, or even more distinct ways all at the same time? It seems kind of impossible. And here's the second major issue he brings up. We see these spectral lines when we look at super hot, excited gases. But think about it. That intense heat should be knocking the electrons clean off the atoms. That's what ionization is. So if the electrons aren't even in their orbits anymore, how can they possibly be jumping between them to create the light we see? It's a real head-scratcher. And as you can probably tell from this quote, the author is not shy about his opinion. His point is that the whole idea of an electric field just gently shifting an electron's orbit doesn't make mechanical sense. It's like if you nudge the Earth out of its orbit, it wouldn't just settle into a new, stable path. It would fly off into space. He argues the same logic should apply to that electron. Okay, so if the standard explanation has all these problems, what's the alternative? Well, the new solution starts by completely redefining something incredibly fundamental, the concept of charge itself. This is the huge paradigm shift right here. The theory says that charge isn't just some abstract property, some plus or minus sign we assign to particles. Nope, it's a field of real physical stuff, a constant flowing sea of actual photons filling all of space. And this physical field has rules, it has mechanics. So you've got this ocean of photons everywhere. The theory suggests that atomic nuclei are like little drains or whirlpools in this ocean. They're constantly pulling photons in and channeling them through and out the other side. And this process, this charge channeling, is what creates all the structure we see. It creates vortices and currents, imposing a kind of fundamental order on everything. All right, so let's follow this logic. If the universe is really a sea of photons being channeled by every nucleus, what does that mean for our understanding of light and those spectral lines? Let's see how this new foundation changes everything. What's so interesting here is that this new idea completely flips the script. The mainstream view says it's all about electrons inside the atom, jumping between orbits and spitting out photons. But this new view, it says spectral lines have nothing to do with electrons bound to an atom. Instead, it's the free electrons, the ones just floating around in the field outside the atom, that are doing the work. And they aren't even creating new light. They're basically catching and rethrowing, or recycling, the photons that are already in the field, just at different energy levels. Okay, so let's take that new foundation, the idea that free electrons are recycling photons in the field. With that in mind, the paper finally gives us a purely mechanical reason for why those spectral lines shift and split when we apply an electric field. The key is that we've been oversimplifying the problem. It's not just an atom and one external field. According to this theory, to really understand what's happening, you have to account for the complex interaction of 3 separate physical fields all at once. So what are these 3 fields? First, you've got the element's own natural charge field that's always there. Second, you have the field you're using to heat the gas up, the one that's causing the spectral lines to appear in the first place. And then finally, you add that third field, the one that's specifically causing the Stark split. The effect we observe is the result of all 3 of these things mixing together. This new model also neatly explains why the split is often asymmetrical. It's not always a perfect even split. The paper argues it's because the free electrons that are further away from the hot gas are a bit cooler, so they're spinning slower. When photons hit these slower spinning electrons, they get deflected differently than they do by the faster spinning electrons closer in. And that difference is what causes the uneven split we see. So you see how this all builds up? From a specific mechanical explanation for one little effect, the author then zooms way out to make a much bigger, almost philosophical point about how the universe actually works. This quote really gets to the core of it all. The big takeaway here is that the universe isn't built on a foundation of randomness and chaos. It's built on the pre-existing physical structure of this charge field. So what we perceive as chaos is really just a level of order that's so complex we just don't understand it yet. You can't get order from nothing. You can only get it from an order that's already there. And this brings us to a really fascinating final thought to chew on. What's the real goal of physics anyway? Is it just to build mathematical models that can accurately predict what's going to happen? Or is it to actually find the tangible, physical machinery behind why it happens? This paper makes a very, very strong case that we should be looking for the machine.